Yeah, so this is the module one. We will be starting with module one today. Basically, it's the introductory module, introduction to chaos engineering, and here we will be seeing like what led to the rise of chaos engineering. Some like the products which were developed and which give rise to chaos. Then the principles of chaos engineering, which is very important because whenever you start with a domain, if you don't know the principles behind it and what are the processes available, it becomes difficult for you to communicate within the community and also to understand what it is. Okay, then that we will try to see. Then chaos engineer, like if you are a chaos engineer, what are the activities you generally perform as a chaos engineer, the process of chaos engineering, the prerequisites, okay, few which you need to take care. Then we'll also see some basic experiment today, like how you run a basic experiment in Gremlin using the tool, what are its different functionalities, etc., which we will see as we progress, because Gremlin is a bigger tool, so it will take time to cover everything. So today we'll be starting with the basic overview of Gremlin. Then with as we progress, we will be learning it. So, right. So rise of chaos engineering. So what led to the rise of chaos engineering? So why do we need one more chaos engineering? So like let's say you have already functional testing, you have automation, you have performance, you have different testings available now, right? Even some some do like even there is a failover testing, right? As we correctly pointed out. So now what is the requirement of one more testing, or we can say one more testing practice suddenly? What changed in the background? Okay, so what led to this requirement? So basically, so the main change which happened was the advent of distributed systems. Okay, so when the distributed systems came into picture, the systems became very complex. Like for example, if you see a distributed system, like let's say if I take an example. Let's say if you have a system like this, okay, this is a simple system, we can say simple application which has two interfaces. One is a mobile app, okay, and the other is using the um, web access, okay, web services. Now the thing is here, this is a service. Let's say this is a service where you book your tickets and all, no? Like let's say like some make my trip, or okay, some application like that. Now the problem here is, see this, the good thing what you can see in this application is these are like based on microservices. So what are microservices? Like for example, this is a passenger management microservice, driver management, trip management, passenger web UI. So what is the can anyone say why do we go with the microservices? What are its pros to go with microservices? Anyone?
Portable, one thing.
Lightweight.
Yeah. So one is lightweight, obviously. The other thing is, see, the microservices, the main advantage of microservices is your development becomes very independent. Okay. So let's try to understand that. For example, now if you have payments, okay, and if you have let's say driver management, these are the two microservices which we are now focusing on. Okay, so now the payments microservice, when let's say it is developed, the developer of payments microservice is Mayank. Okay, test team, let's say we have Srinivas. Okay, then driver management, let's say the development is handled by uh, Sri. Then we can have let's say Praveen as the test person. So now see, the development the developers are different, the testers are different in both the microservices. Okay, now what will happen is, let's say Mayank is developing something and Sri is developing something. Praveen is testing it, Srini is testing it, and they are pushing it to production. Can we do that with the microservices? Like there is no link between Sri and Srinivas when they are developing. Like they can do it independently. Can they do that with microservices?
Yes.
Yeah.
Correct.
Yes.
So that's the main advantage. Okay. So because your go to production, or we can say the time to production your application reaches is very fast when you have microservice, because there is no dependency between each other. They all communicate between each other using APIs. Okay, and only that is the part where the integration happens. Only that is the part where they have a dependency. But otherwise, the development, there is no dependency. The other thing is, let's say Mayank is using Go programming. Okay, and Sri is using Java for developing the backend. Okay, can they do that with microservices?
Yes, they can do.
Yes, that is also a pro, right? With the microservices, there is no limitation of what components you use, because they all act independently. Even the DB they can use differently. Like payments uses, let's say SQL DB, driver management uses Oracle DB, or let's say payments uses some other Dynamo DB, let's say, and your driver management uses like let's say some other DB like some MySQL DB. Okay, so that way also there is lot of flexibility. Like you can use a lot of different languages, different architecture, even the different services, right? And even the deployment becomes very simple because there is no dependency between each other. And So that's the thing. Okay, with the microservices, now these are the pros, but with the pros some cons will also enter into the picture, right? So what will be the cons? So when we speak about the con, what will be the first thing which will come into your mind? It's very complex, right? So this complexity will lead to problems. See, for example, payments is on Go, driver is on Java management, Java, then DB, here it is Dynamo, here it is MySQL. So the testing which you do here and testing which you do here, can it be same? The analysis, or let's say the process which you are following, can it be same?
Maybe different.
Different, right? And also, so now the main problem will arise. When will the problem arise? When they get integrated, right? When they both communicate with each other. So this is the place where the real problem will come. Okay, and that's what happens. That is what, okay, or that's what led to the chaos engineering, because this chaos, right, between the applications, or this lot of permutation combinations, and this is leading to conflicts, or we can say not only conflicts, problems which are leading to outages, which is hard to find using traditional testing practices. Like the traditional testing practices cannot uncover those issues because of these complexities. Okay, that's what led to chaos engineering. Okay, so this type of systems are also called as distributed systems, and more closer to this, like for example, the more closer systems are the cloud systems. Okay, on-premise ones are not that chaotic compared to the cloud, but cloud is again very complex. Okay, there is microservices, there is auto scaling, there is lot of other factors which are coming into picture when you're on cloud. Okay, then there are third-party services which are communicating with the system, and so that way it becomes really complex, and this complexity leads us to a requirement for a testing practice which can uncover those potential issues, okay, which is creating the outages due to these complexities of the application, right? Okay, so that's the one thing why the chaos engineering is like nowadays very common. Okay, because if you see, it has become very common in past few days, for few years we can say, right? So that the reason is mainly this. Right. So one is complex distributed systems. We have it. Then the cloud architecture, microservices, etc., which we saw. Then the outages are too expensive. Do you think, like, can we have outages? Like, what do you think? Like, okay, you might think, okay, it's happening only one day, in maybe or one or two times or three times in a year, the outages are happening. Okay, but though, is it okay to have these two to three outages? Like, is it very it's not, is it not too heavy for the business, or is it very light, like based on the money or the like, let's say it's very less costly to have two to three outages? What do you think per year? Let's say take the
Sometimes
example of Amazon.
costly.
It's very costly, okay, because if you see the 2022 year, there were two to three outages in Amazon itself. There were newses, okay. And if you see the loss which they faced due to these two to three outages is $2 to $3 million. And the outage was just for minutes, okay, like 5 minutes or 2 minutes in that range. But if you see, the loss was $2 to $3 million, okay. So it's a very huge amount, right? Now, these two to three outages they could have avoided. Okay, this is not said by anyone, but they themselves. Okay, so this could have been avoided if they had a proper testing of those systems before that issue happens using chaos testing. Okay, so if they had recreated those issues, okay, which happened, and they, if they, or if they had simulated those issues and tested it and fixed it, they could have saved those money. Okay, so now $3 million is a very huge amount. Okay, and if you keep a chaos engineer and if you test it, let's say 2 to 3% per team also, okay, they will not, that will not be this costly, right? See, if you see the $3 million amount, it's around coming to in Indian rupee, it will come to around 30 lakhs into 80, right? So it's somewhere around 24 crores, right? Anyway, if you set up a whole team also, this much amount will never be lost. And obviously with this, not only the outages, right? If you do some chaos engineering activities, it's sorry, it's not only the outages, but you will be uncovering other potential issues also, which might affect your system in future. Okay, so one is the money, obviously, which is one ROI which they get from chaos engineering. The other is a customer goodwill. Do you think this customer goodwill is very important for a business? Money is
Yes.
fine, they lost it, but customer goodwill for a brand like Amazon or Google, do you think it's very important?
Yes.
Correct. So that is also a big deal, right? Because see, a customer is coming, and if there is some outage happening at that moment, that person might go to Flipkart and he might not return. Okay. And that is a very bigger loss than this $3 million, because it's a cascading loss. This $3 million loss, okay, it happened, that's fine. But that customer who left, he might not return. Okay, so they have lost a customer for a lifetime. Okay, so that's a very big loss which they have to face. That's again a problem which we address using chaos engineering. Okay, by controlling these outages. So that's how important chaos engineering is as a business perspective, and that's how valuable, well, or we can say that's the number of that's a value you can add to the business by giving proper solutions. Okay, right. Then outages are too expensive and it's a vaccine. So chaos engineering is like a vaccine, okay, most of the time. So why do I say it's like a vaccine? Because vaccine is more sort of precaution than a, like, if your issue happens and then you fix it, okay, than a fix. That is, okay, that might be useful, maybe in the future that issue will not come. That is one thing. But chaos engineering is more sort of precaution. Like, why do I call it precaution? Like, before that issue happens itself, I will have to fix it, or I will have to simulate those issues recreate those issues or create those issues and fix those issues, because when it happens in production it's too expensive, okay, which we can't bear. Okay, so we need to be ready for that. So let's say if you have 2 to 3 outages yearly happening, maybe you cannot make it zero, okay, but you can bring down this 2 to 3 to 1. So that itself is a big achievement as a chaos engineer which you have. Okay, so that's why it's more sort of a precaution which we are focused on. And fixing, yes, obviously we can, after the issue happens we can recreate those issues and fix it. That is also there, but more but before the issue happens, if you can fix it, that's your big win. Okay, right. So now if we see the history of chaos engineering, okay, first, chaos engineering was introduced by a company called Netflix. Okay. Now, why this Netflix introduced chaos engineering is, first of all, they were moving on to AWS. So their systems, they were moving on to cloud. So as I said, cloud plays a very vital role in chaos engineering. Wherever there is cloud, there chaos engineering has to happen. And also, when their cloud dependency is very high, chaos engineering will surely happen. Okay. Then Netflix introduced when they were going on to technology transformation, they were going on to AWS. So that time they introduced a tool called Chaos Monkey. Okay, because they knew with the cloud advent of cloud and the advent of how they were scaling their system by making it distributed, from all this they needed some domain, okay, or some testing practice which will uh, uncover those potential issues. So they introduced or they created a in-house tool called Chaos Monkey. Okay, so now this Chaos Monkey had some limitations. Okay, the main limitation with the Chaos Monkey is, first is, when this Chaos Monkey was introduced, the chaos engineering was a very, we can say, primitive practice, or we can say it was just starting off. Okay, so there were no processes, or it was done by just for some specific attacks, or we can say a specific objectives. So Chaos Monkey was only supporting an attack which was shutting down the nodes. Okay, so that was the only attack which the Chaos Monkey used to support. Now, what they did is they pushed this Chaos Monkey code into GitHub after a few years. Okay, so that even others can also use it. They made it free. Though they developed this tool, now they made it free. Okay, so with this, there was a big difference. Okay, because what happened was, people tried to get into this field very like proactively. Okay, because now they had a tool to work on, right? And so what they did is they used this tool to test their systems also. Right, so now after Chaos Monkey, they also created some other tools like Chaos Kong, Chaos Gorilla, Chaos. Basically, these tools, what they did was they increased the attacks. Like what Chaos Monkey only supported like shutting down the nodes, right? Then they needed latency attack, different attacks. So they created Chaos Kong, Chaos Gorilla. Now that whole package they called it as Simian Army. Okay, so Chaos Monkey, Chaos Kong, Chaos Gorilla, everything together, they called it Simian Army. Okay, now this happened like when they introduced this Chaos Monkey into GitHub, it was, I guess, around 2012. Okay, so around after 2 years, around 2014, what happened was, uh, there was an engineer who worked in Netflix. Okay, who was behind this Chaos Monkey development and all. So he left Netflix, okay, and started a company called Gremlin in 2014. So the person who started Gremlin actually was a pioneer in chaos engineering. Okay, he was the person who was in the team of chaos engineering in Netflix, who developed Chaos Monkey, and he started Gremlin in 2014. His name is, I guess, Colton Andrews, some and and yeah, so they've co-founded like he's a co-founder of Gremlin, and that's how this Gremlin came into picture. Now with the advent of Gremlin, things changed drastically, okay, because till now we were having a free tool, open source tool. Now we had a paid tool in the market. So paid tool plays a very different role in the market, because paid tools give you a lot of flexibility, community support, right? And that way you can really get into the picture of, or we can say really do something with the chaos engineering, because there were people who were really good at that, right? If you so in that way there was a revolution happening in chaos engineering. And now what happened is around 2020 again, AWS, what they did, they added one extra service called AWS FIS. Heard about it? Basically AWS fault injection simulator, we call it, okay. This is also a chaos tool provided by AWS, but the problem with the AWS FIS is you need to have a good hands-on with the tool. It's like little bit code based and all, so you can't do it by just a GUI clicking and creating an attack like Gremlin. You can't do that, okay, with FIS. So that's how. Then see what happened was, so basically what I'm trying to say is AWS FIS, with the advent, what happened, things became very popular, like chaos engineering was now in the mainstream, okay, and people were trying to progress with it. So that's how you can say the history of chaos, okay. So it started from 2010, we can say, okay. Then 2012 it came as an open source out, 2014 Gremlin, and now you know what's the story. There are a lot of tools which we will discuss and compare, and we will come into a conclusion like why Gremlin and Chaos Toolkit is some of the commonly available better tools in the market. So now let's do one thing. So any question, anyone till now?
Yeah, Vishnu, I have a question. Like this
Yeah.
can be used only in the cloud-based applications where distribute. If it is a monolithic application, then how chaos
Mm.
engineering can be used?
Similar thing. So there is no major change. But what I meant is, see, if you have a cloud, there are a lot of services in cloud which you can test using
Yeah,
Chaos.
understood.
Now
Like
in mono,
Kubernetes, like all the pods and
correct,
everything, we can test
correct,
that. But in
correct.
monolithic, maybe
Hmm.
if DB goes down, everything is gone. So how do we
Correct,
test?
correct. Same thing, same thing. No, no difference. Okay. So in monolithic systems also, you need to install these agents on the DB server and your web server, your what all servers you have, no, in those, and then you can attack those servers specifically.
Okay.
Yeah, yeah. So there is no
So
major
you
difference.
mean
Yeah.
cloud
Go
will
ahead.
have more
Mm,
opportunity to do the cache engineering, like if they use
correct,
uh,
correct.
cloud-based
Correct. So
application and also Kubernetes plots, clusters, everything, right?
correct, correct. So the thing is, but I will always say it's if
Mhm.
you are new to chaos engineering, you can start with monolithic, because why I am saying monolithic is if you already have a cloud, also not a problem. But if you have a monolithic systems, you can actually play with the basic fundamental attacks like the CPU attack, the memory attack, the black hole attack. Okay, and then once you are well versed in those attacks, you can move on to the cloud. So that is also a good way to start with chaos engineering. But if you already have a cloud, not a issue, you can start with these attacks, then progress to the major attacks like the DNS attack or those type of attacks. So that not directly we will discuss all these attacks, I'm not coming to
Oh,
that now. Yeah, but what I meant to say is monolithic, let's say you can do 50% in monolithic and 100% in cloud.
okay.
One
That way you
question,
get.
Vishnu.
Mhm.
Yeah, these experiments are performed only in non-prod or production also.
In production also, so basically that also we will come here. So this production, when we listen, okay, or when we hear, we get shocked, because uh it's like it's little tricky there, okay. So what generally happens is people don't get to directly do it on prod, okay. So what they do generally is they will do it for the lower environments, okay. Once they get that, like everyone has that confidence in you that you can do properly some test cases in production, you get the chance to do it in production. So we will speak how that process works, and how you do it, what are the precautions you need to take, and how you try to reduce the risk in production by using the lower environments. We will speak about that when we see the process, how you run these experiments.
Vishnu, one more question. Like, we have already, like, I can say that, see, like CPU extraction or memory extraction. So we will be
Hmm.
doing through the performance testing as well. Then why do we need
Correct.
the class engineering?
Okay, so that's a good question. So see, let's say you are using LoadRunner. Okay, LoadRunner has a license of 10,000 users. Now, let's say you have a cloud. Okay, and after adding 10,000 users, also your CPU is not getting exhausted. What you can do in that case? Your license is gone, right? 10,000 users is your
Okay,
license.
let's take some buggy software which can make you the CPUs, not the load
Hmm.
testing. See, we
Correct.
know that
Okay.
in load
Hmm.
testing, pumping the load, making those many transaction, you may not reach
Uh,
to CPU or memory.
correct.
So let's
Correct.
say that there are so many buggy softwares are available, which
Okay.
if you run
Hmm.
one command in Linux, it will reach your
Correct.
CPU
There
or
are. Yes. Yes.
memory.
Great.
Then how
That's
does
what.
it
So that's
different?
what
My
is
question is,
that.
how does it different from that buggy softwares and the chaos engineering?
Correct. So that is where the Simian Army softwares are. No, they are all different softwares. One, two, three. You need to install all those agents on those machine, and then you can run. It's a free software. Okay. No one is stopping anyone to use those software. But the problem with that is, see, the main issue comes, like, let's say I have a scenario where I need to run a latency attack. Okay. Then after 5 seconds of delay, I start a CPU attack, then parallelly, I start a memory attack and then combine it with a black hole attack. Can you do this using any software?
Maybe if we run all this buggy software like CPU memory at a time parallelly, I'm
Yeah,
just
correct. But are can we, like, because see, we need to install and set up all these softwares, and we need to parallelly monitor, control. Is it possible? It's possible, but is it like I meant, see, you are testing for reliability, but you are not sure whether your application itself is reliable or not. What you are testing, right? Application means your tool itself. You need to be very sure, like, whether the tool which you are using, the ways which you are creating these issues are reliable or not. If that is
oh,
reliable, then only you can test the application reliability, right?
okay.
So what I meant to say is, when you do it in that way, it becomes very complex. Okay, so to monitor or to start, or even rollback. See, it's a very important
Maybe
word,
this we can
rollback.
say as a automated cache engineering tool will give the automated process with all these attacks and the reports and then the time taken to recover all those things. Maybe right.
Not
We
I
can
will
say
not
an
say the
automated.
reports. Correct. Reports I
Mhm,
will not say, because reports which we use is the monitoring tool which we have. Like, let's say if we have
mhm,
AppDynamics, we integrate Gremlin with AppDynamics and all. In that way, we generally do it. So Gremlin doesn't provide a reporting, and the reporting which Gremlin provides is very basic. I will show you that. But the main
mhm.
thing is rollback. Okay, rollback is a very important word, because see, if you create a shutdown attack on Chaos Monkey, sometime that pod doesn't come up, and no one you can question. Okay, but in Gremlin it doesn't happen like that. If you run a CPU attack or a memory attack for 5 minutes, after the 5 minutes, surely that memory will come back to the normal how it was before. If your application is not reliable, it will not come back. Then you have to fix it. That's a different story. Okay, but in Chaos Monkey or some other open source tools, when you run a CPU attack, we have observed what happens is, like, let's say you run 100% or 90% CPU attack for 5 minutes. After 5 minutes, what happens is your CPU will either get stuck, or I will not say CPU, let's say memory. Okay, memory will get stuck, or your whole service will crash. Okay, but that is happening because your rollback is not proper. Like, after 5 minutes, it has to roll back to the previous state. But in Gremlin, it is very like, they handle it very clearly how the rollbacks happen. Okay, so those
Okay.
are the, I can call out like few of the pros. See, now again, it's like it's debatable, right? Like if I say, okay, I'm using Jmeter, there will be some other tools which can do the same things like Jmeter, right? But again, it's more sort of, but Jmeter is a performance testing tool. It's not a development tool. So a development tool, if someone has, which is very close to Jmeter, they cannot say it's equivalent to Jmeter because it's a specific tool for performance testing. Similarly, Gremlin is a specific tool for chaos engineering, right? It has it. You can create scenarios, you can create hypotheses, you can create game days in Gremlin, which in all in one tool, right? That's what makes Gremlin a chaos engineering tool. Now if you want to create, there are open source tools, right? Chaos toolkit is there. If you see the chaos toolkit, or let's say other open source tools like chaos blade, you will not have many functionalities which Gremlin has. But the problem with that is, again, as you said, right, you will have to do lot of work on your own. So when you are doing this, will you monitor your test, or will you analyze your test, or will you set up your test? I meant, like, will you spend time on setting up the test more, or monitoring and analysis? That comes a question there. Okay. So whether you want to spend more time on setup or monitoring and analysis.
Okay,
Clear?
understood.
Yeah.
Sir, I
Okay.
have
So I
two
have a
So any
questions.
other
question.
question? Yeah.
I have two
Uh,
Yeah.
questions.
My.
yeah,
So,
okay.
sir, in the previous slide, where you are showing some distributed architecture from microservices, you have mentioned that,
Correct.
okay, so individual services that we have created that are independent to any software, any code, okay, we can develop individually and after that we integrate. Correct.
Correct.
So when they integrate, so chaos will come into picture when we are going to integrate those microservices. Correct.
Correct.
So
Correct.
what
Yes.
kind of issue that we may encounter while integrating? Because anyhow, if we go about the testing life cycle for different types of testing, I'm just referring. So we do
Mm.
functional, okay, we
Correct.
do security, do performance, we do resilience testing, we do failover
Correct.
testing.
Yeah.
So if we do these type of testing, so we can also already test all these type of issues, correct, that may encounter
Yeah.
when we are going to integrate. If the application is not integrated, if the services is not integrated, okay, then even the functional testing will
Mm.
not pass, correct.
Yes.
then
So
then how this chaos will come
correct.
into picture
Mm.
in that case?
Correct, correct. So coming to that, okay. So now let's say I have an example of a MongoDB. Okay. Now I don't know, like you would have heard about MongoDB, but
Yeah,
let's say there's a DB called MongoDB. Maybe people would have heard also. It's a very common DB nowadays.
yeah.
So in MongoDB, we generally see a very common problem of primary promotion. Okay, we call it promoting a secondary cluster to a primary we can say node, secondary to primary node. So in MongoDB we generally see this problem where the secondary node doesn't get promoted to primary node due to some configurations which we do in the MongoDB. So
But we
configurations, who decide the configurations?
dev
Architects,
architect
right?
and dev, yeah.
So they set up the CPU limits, memory limits, and all. Now when you test it with performance, it might work fine. When you functionally test it, it will work fine. But the problem when this is seen is when you purposefully bring down a zone, okay? When you run a zone attack, okay, or when you run a DDoS attack.
Mhm.
Now this you can't do using performance, right? Or a functional.
we
Now
can
see
do
what happens is,
we
yeah, we
can
can
do
do.
we can
That's what.
do
So that's what I'm saying. See, it's not that this here we are able to do only what. See, it's more sort of you all need to understand it in such a way. What are the objectives, right? A performance tester objective is not recovery, or let's say how the customer experience is, right? His objective is load and stability. So he will focus on only those test cases. And
understood.
now a performance
Sir,
tester can do this chaos engineering activity, right?
sir, I understand.
Uh,
Just leave it
correct,
performance. Just talk about only failover and resilience testing. Correct.
correct.
So in the
Yes,
failover,
yes.
we also shut down the node. Correct. So
No,
that the
we don't.
second the
That's what. So we
will
let's understand failover very clearly. Okay. I guess many people here have this doubt. What a failover is, because
everywhere,
the
sir.
objective
I've
itself.
done that thing. Everywhere has
Yeah,
different
yeah,
way
yeah.
of doing the testing.
Correct,
Every
correct,
company has different way.
correct, correct.
Correct. So
Correct,
intensely we
correct.
bring down the test, then the secondary node will become the primary one, and
Yeah,
we
yeah.
carry out the
Mm.
test just to ensure that everything is working as expected. Correct.
Correct, correct, correct. Yes. That is only one thing of failover. Okay, that's
Mhm.
only I meant like see if there are different components. Let's say here you are talking about only the nodes. Okay, let's speak
Mhm.
about DB. How do you do a failover testing in DB?
So so DB in the same way, because we have the active and
Is it
passive.
is it is it no is it
Sorry.
no failover testing in DB doesn't happen like does it happen like similar to a node? Are you sure?
No, no, I'm not saying that DB will be similar to the node. I'm saying that if we have the
Okay,
active
let's
and
say
passive,
let's leave DB. What about queuing services? Will it be same?
no,
So that's where like so that's what I'm saying. This failover testing, what you're speaking about, it's all about how your system will withstand any failure. Okay, this word is very important. The objective which they are looking for. Okay, because see, if your objective changes, what you're doing will change. Okay, because that's what you're fixing. Your make metrics, your KPIs, everything will change with the objective. Okay, now this withstanding of the failure, we are not at all interested in chaos engineering. And also the main thing is, can you say any testing which happens in production? Anyone? Can you call out any testing which happens in production other than read only? Okay.
sometimes security.
Security is fine. Okay. But any other text testing like performance or like which is non-functional which happens in prod.
Re-
Security is fine. Okay.
Sometimes
That is again read only. That's again read only. There is no nothing they push like right. So something which is more sort of not only get or it's something like
it
post
depends on the
also.
type
Okay.
of client, but the resilience testing can also be done in production. It depends on client to client. Correct, and depend on the type
Correct.
of
So
application. Yeah,
there comes the point. So this resiliency testing, is it similar to chaos engineering?
very much similar.
It is, right?
Yeah.
Because that is what this resiliency is what is the see what this resiliency testing we used to do. Chaos engineering is the father of that, right? I meant resilience. It's not that we are doing anything different than resiliency testing. That's why we say reliability, reliability, reliability again and again in chaos engineering, right? But chaos engineering is a little next level of resiliency because in resiliency we were speaking only about okay so what do we do in resiliency, Mayank? Any example you give test case?
I've never done that resilience testing, so
So
I can't give
that's
the
what
term.
so that's what I'm saying. This resiliency testing, I never said resiliency testing is not similar to chaos engineering. Okay, because chaos engineering is the next level of resiliency testing, but here we were
Okay,
comparing failover and chaos. They are two different things. Never compare
okay.
both of them. Yeah, because see, one is withstanding the failure and one is the recovery. It's very, very different topics altogether. Because see, now if I say I have an application which can recover in or let's say 2 minutes, okay, and I say there is an application which can, okay, both let's say we speak about traffic, okay, let's say 1 lakh users, okay, 1 lakh users when they access this application, my application recovers in 2 minutes. One hypothetical case I'm saying. When 1 lakh users are using my application is able to withstand or like there is no point of recovery there. Your system is able to withstand. Okay. Like there is no failure happening. Though response time is shooting, let's say 10 seconds. Here, normal cases, if it is 2 seconds, here it is 10 seconds. Okay, this is failure. Now let's say this is like your system is not failing at all. Is both this scenario same? If you say both are same, I will say chaos engineering and failure is same.
No, no, we didn't bring down the system in failover.
Cor- Correct. So that's a very, very important thing, right? Here the system is coming down, and then what you will do next? That's the solution, right? In this 2 minute of time, will you lose your customer? Okay, so to not losing the customer, what all fixes you can do, or
So in
whether
that
can you do technical fix or can you do some
so in
design
that way,
fix?
if we can define in that way, so chaos engineering, how we can quickly up the system, how soon
Correct.
we can up the
Correct.
system and running. Yeah, if any
Correct.
kind
So
of
that is more about, that is the
okay.
objective which we have. Okay. And that in that way only we will create our use cases. We will never create use cases where we speak about response time or load or failover. Our use cases or our test cases or our hypothesis, we call it, will be around those objectives only. Okay. And that is where I said, I say to everyone, like whenever you are doing some testing, see, even a performance tester can do some functional test also. Okay, even a functional tester can do some performance test, but is it correct if you take their test cases and you do? It's not correct, because you have to be focused on performance, the load and stability. So if you want to be focused on that, you need to be very clear what are your objectives. Otherwise you will pick up all the test cases which are maybe not out in the scope of performance at all, right? Which is happening, I have seen. Okay, people who are doing performance and they add the test cases which comes under resiliency, and I just clearly call out, like, why you need to waste time on that? Because there are other chaos engineers or resiliency tester or manual testers to do that. Why you need to do that, right? Some places they waste time on low volume tests. Low volume test is like they add some 10 users and they try to test it. I say no, there's no use of that. Okay, what they need to do is not a performance test there, but a code profiling. So everything has a specific objective. Okay, so you need to work in that specific boundaries. Otherwise what will happen is the boundaries will mix and your test cases will shoot, and there will not be any clear what we can say expertise or a clear tuning of the application which will happen. Clear, Mank, what I meant to say? So the failover and chaos, yeah, you need to have a clear boundary.
Understood,
Then
sir.
only
Understood.
later on, yeah, yeah, otherwise later on you will face issue when you are creating the use cases and all.
Okay. So I have
Yeah,
another question. You have used the
yeah.
word called restore. Correct.
Restore, when did I use?
That means suppose if for the chaos engineering, okay, what will happen that if
Mhm.
we do CPU attack and anything, how recover, not restore, recover. Correct.
Okay,
So
rollback.
rollback, sorry, yeah, rollback. This is the
Yeah, yeah,
term that you
okay,
have.
huh.
Yeah.
Okay, okay, yeah.
So what does it mean rollback? That generally we use the rollback term in the database when we take the
Correct. Mm.
backup or the
Yes,
flash. Yeah, we
correct,
create
correct,
some points and after that we roll back. But in chaos
correct,
engineering, suppose if we right now we are going to do the do some attack. So
correct.
before that, we take any backup so that we can roll back to that
No, no,
backup.
no. See, correct, correct. So that's where the rollback means, what I meant there is, see, whenever you're running an attack in Gremlin, okay, so there is a state. That's where the principles of chaos engineering, when we discuss, you will come to know. We speak about a steady state. So there's a state at the beginning, okay, when before you start the experiment. Then there is a state which comes after you do the experiment. Okay, both should be same, then only your experiment is we say your system is reliable, okay, or resilient. So now, before and after, if they need to be same, what I'm injecting in between, like the gremlin or whichever tool is injecting that. So let's say you are you are running a memory attack. So generally, how can I add memory to a, like, what will be the process that software will be using to add memory? What do you think? Like,
So generally in the
how
cloud,
mhm,
so generally we do
how it will be doing?
horizontal and vertical scaling. Actually, it depends how we do. We do the scaling
No, no, no,
horizontal and
not
vertical.
not memory addition. I'm saying increasing the memory. How does it do? How, let's say a gremlin or a software can do it easily. Like, like if your memory is building up in your in your resources. So what is happening in your system? Like, why you require more memory?
because because of user load.
So more objects are being created, right?
Correct.
Like
Object
you
in the
run
heap.
more processes, more objects. So right.
Yeah,
So Gremlin will also do the same thing. Okay, it will also try to create more objects and fill the memory to what level we gave. Let's say. Okay, now this is done. Now what if it leaves it in that way and doesn't bring it back? Like what all objects it created properly, it has to destroy that also, right?
got it.
So that is a
Now I
place
got
where
it.
I said rollback. Rollback.
Now I
Okay.
got it.
So
Now I
there,
got it. Yeah.
what all injection we are doing, the method we are doing to inject that failure, it has to bring that injections back to normal also. Like what, how my system was before, without leaving any signature behind. So that Gremlin can do very well compared to other chaos tools nowadays.
Okay.
Clear,
Thank
man?
you, sir. Yeah, yeah, now
Yeah.
understood. Clear.
Yes, yes, yeah. So
Vishnu, this
one
gremlin
example
can
of
be,
memory. Yeah. Go ahead, Sri.
yeah, yeah, this gremlin can be integrated with Dynatrace and like a model, like logs tools like Splunk or ALK something. Okay,
Yes, yes, correct. But
integration.
it's very easy to combine Gremlin with tools like Datadog and all. But other Dynatrace such tools, you will have to do little extra work, like to get the API key integration and all. Little coding you will have to add. But Datadog, it is very simple. They have a, I think, collaboration with Datadog, Gremlin. You directly insert the API key of Datadog here. In that way, Datadog is able to read the attack details and all, no, from Gremlin directly. But for other tools, I haven't tried, but it's possible because there is an API key. Obviously, you can integrate in that way. Yes,
Yeah, sometimes we may need to monitor the logs also, right, using a
correct,
Splunk or
correct. Yes,
ELK.
yes,
So
correct.
yeah,
We
okay.
can do that. Yes,
That's-
because all these are like there are a lot of Gremlin APIs available. Using those
mhm.
APIs, you can easily get the data and create a like dashboard in these tools where you can monitor these applications or these attacks in your tool itself. But obviously that will take a little effort. Okay, it's not pre-built. Yes.
Hi,
So
sir.
Vishnu,
So,
Yeah. Hi, Srinivas.
yeah, once this experiment is completed, will that Kremlin will give the recommendations where the issues occurring, what we need to do for overcome that issue?
Like that, Gremlin doesn't do. Like there is no, but it will show lot of logs. Okay. For example, logs means like when you ran the test. Let's say your test got aborted due to something, and why that abort happened, like some pod crash or maybe out of memory
Okay,
errors or what. So those logs you will get basic logs. But as I said, Gremlin you can focus more sort of a tool which can be used to till only the execution. Okay, I will not go till the analysis because analysis you will have you I will prefer to use other tools like what you have, the monitoring tools which you have. But Gremlin is a tool which you can use till the execution stage, execution and basic log analysis. I will not say deeper analysis. Deeper analysis, obviously, you will have to have a some free tool like Grafana or Kibana, or let's say even paid tools like Datadog, AppDynamics, Dynatrace. So in that way, you can analyze
okay.
more better.
So it's our role to identify the issue and report.
Correct, correct. But the main thing is, see, like when you are running a test itself, you are seeing the dashboards which you have created. When, like, let's say you are doing performance, right? So you will be creating performance dashboards in AppDynamics. If you even focus on those dashboards itself, and if you can get the logs of those pods and all, which I will show you how you get the log of pods. When you run a test, if someone is new to Kubernetes, I will show that. So by that itself you can uncover a lot of issues. Okay, so and obviously the well, like the chaos engineering, now it's a stage where it's a very new stage, right? Like even developers can understand, if you can provide them proper logs, they can analyze it. Okay, they can find out like where was the issue. Okay, even that's a stage we are now, we can do that. But later on there will be expectation where you provide the recommendations also. Right, let me log into Gremlin.
hi, sir. Just a question. So, all this you do in production environment, or is it a pre-production environment where you do all this?
So it's more sort of, see, around 80% things will happen in lower environment. Okay,
Okay.
20% will happen in production environment. We can say it in that way.
Mm-hmm. Okay.
So like let's say if you have 10 test cases, you might run two on production, and we will see how you choose as to those two. What's the process of doing production test, and how much recurring, how many days of gap you give between production test. What's the window we decide, and all those. No, we will see. That's
Okay.
where I
Sure.
said there is something called a game day. So game days are basically the day when you run the test in production. Okay, so how you plan a game day. So that also these things we will discuss as we progress.
Sure. Sure.
So Vishnu,
Thank you.
Yeah.
so
Yep.
will you deploy application and will you inject these kind of experiments and will you
Correct.
show that?
Mhm. Correct, correct. So I will have a demo application. Basically, it's a free application, which is a microservice based application called Sockshop. So that I will deploy onto this server which I have, and there we will run the attacks, different attacks, and we will see how these attacks are progressing and what we are observing in the backend.
So, sir, what all attacks you are going to cover as a part of this course?
What all?
Attacks that you
Uh,
are going to cover.
attack.
Yeah.
So yeah, mainly I will be covering CPU, memory, the infrastructure attacks, then the black hole, DNS attacks, latency attack. Very because latency attack plays a vital role for a performance tester because it becomes lot of handy. It comes handy many times to combine latency attack with your performance test to uncover some issues. Okay, so that is again the latency attack is very important attack. So and yeah, these examples I will widely use. Then others are there, like for example, there are some attacks like if you see, which I might not cover. I might say what is the use of these attacks because those are not common attacks which generally, but these are the very major attacks which we generally use: the CPU, memory, the network attacks, the latency, DDoS, DNS, because these are very critical attacks. Then there are state attacks like the shutdown attack, all those that also we will cover. Okay. Yeah, so this is a Gremlin dashboard. Okay, how the Gremlin dashboard looks like. So currently there are no, we haven't set up Gremlin for any server. Okay, that's why you are not seeing anything here. Okay, so once you set up any server on Gremlin, or once you set up what we can say, once you configure the Gremlin agent or Gremlin onto that server, you will be able to see the attacks and all here. Attacks means like you will be able to run the attacks. We will see what are host, containers, Kubernetes, what are these options. Now these are disabled, the attack section here, because we don't have any target now. So generally these servers are called targets in Gremlin. So that's why you're not able to see those targets. Then there are some scheduler options, agents, reports. So these reports, no need to confuse with the report of like where you get recommendations or no. It's more sort of the attacks report, okay, where you run the attacks, how many failures pass, like more sort of Jenkins build report, no, we get where we know some basic overview of the attacks and all, or we can say the builds in Jenkins. So those way, okay, these reports are. Then we can create a scenario. So we will learn like how to create a scenario, what's a golden signal. When we go ahead, okay, golden signals are more sort of error handling. Okay, in performance we have error handling, right? Like assertions or some in that way. So in golden signals are also similar to that. Okay, then game days, we will see how to create a game day, what's a game day and all, in like how you create a game day in Gremlin, that also we will see. Yeah, and in attacks mainly, okay, the major chunk will go in attacks and scenario creation. So attacks, you will see like how you create the attack, what are the things you need to take care when you run the attacks, base different types of attacks, and where do we use these use cases. Like for example, latency attack, where do we use, if you have a shutdown attack, where do we use, what type of scenarios we need to go with that. Those things also we will see in the next session. Okay, because today it's almost 9. I thought I might show a small attack today, but yes, as our discussion got little longer, so we will continue this tomorrow. And in and I'm happy like there is interaction because it makes, as I said, makes the whole crowd little interesting, uh, interested in the topic also, because there will be a lot of things. Now even me and Mayank, when we spoke regarding the failover, and so in that knowledge exchange itself, there were a lot of uh, extra things which everyone would have got, even myself, okay, which I would have thought about. Okay, so yeah, so that's a good thing. Keep interacting. In that way, we can even the hours becomes little extra. Also, I'm fine with it due to interaction. But let's make the sessions interactive. Yeah, so let's start the Gremlin in the next session. So next session will be Monday. So let's start Gremlin this dashboard. We will see some basic attack on Monday, and also we will continue with the modules. Like we need to understand the process of chaos engineering, where we speak about the steady state, hypothesis, and all those. Um, Yeah. So any question? I can take up some question, or we can continue.
Sir, one question is, so Monday, if you are going to start from, will show us something in the Gremlin. So, is there anything that we need to do, you know, just to create any account in
Uh,
Gremlin? How to?
no, actually, what I will be doing is you can now I won't be adding you as a user because once the final if you send me your email IDs, I can add your
Sure,
user like to this account. Okay, so you can use this account. It's a enterprise version of account, so I can add you to like this company like uh, there's something called company settings. So here I can add you all. Okay, then once uh, I add you, you can access these dashboards, you can run the attacks and all. Okay, so that we can do. So you don't need to create some free trial, but even you can try creating a free trial. There is something called, but it takes time, so better. Okay, you can start now itself. Just go to Gremlin free trial. There was something called, yeah, I will send you the link. Okay, it
sure.
was somewhere here, because now they have changed the UI little bit. So yeah, see here, start your 30 days. So they are giving 30-day free trial. You can enter these details and you can click on this. I guess you will get an email. Okay, but generally what happens is I have seen in my students community that when they send this form, they get the reply very late. Okay, so
But the
from
first
the
point, sir,
Gremlin.
it's saying that get immediate access to Gremlin RM. So probably they might have they might have changed something.
Yeah. We don't know. Yeah, I think they will have to do a reliability test on this form first. Let me see if I can contact this person here. I have a friend in Gremlin who is working, so I can maybe ask him like why this process is taking so much time. Yeah, I will do that. Okay. Anyway, so this one also you can use. I will just put this form in the chat. But anyways, I will give you the enterprise version. So it is better than free version because you will have a lot of not limited things. Okay. So but again, it will be for a limited days only I can give because to keep that user count in limit. Otherwise, users will keep on growing. So they might then remove my enterprise free license. Right. Okay. Yeah. So any other question? Tafim, Sri,
Oh,
Raja.
one
Yeah.
basic question, Vishnu. We were
I'm good,
talking
thank
about,
you.
yeah, you guys are talking about resiliency, right?
Yeah.
Resiliency testing.
Correct.
Basically, this chaos is next level of resiliency. So I'm
Correct.
trying to get the exact difference between resiliency and chaos. Basically, first I want to try to understand resiliency. Just
Resilience is the subset of chaos.
Correct. So see,
subset,
basically, Sri,
subset
what
means.
happened? No, when this chaos engineering came into picture, as I said, it's a new. So that time, people all to, use the word resiliency because that time monolithic systems also they were testing. Okay. So once the cloud
Okay.
also got introduced widely into this testing, it became chaos engineering. You can say it in that way. Okay. So
Okay.
in resiliency, main focus was on only those type of attacks which were also being done in the monolithic. Okay.
Okay.
But once the cloud also came into picture, there were a lot of other attacks also which got added, and that all together with some principles and some processes and all became chaos engineering. Clear, Sri?
Yeah, I got it. Thank you.
Yeah. And mainly see in resilience, there is one thing. Okay, there we mainly look into attacks like we try to, like if you say like I filter out the attacks which are focused in resiliency, there the attacks which we focus are to create the stress in the system. Okay, like mainly the CPU memory in that way. But the attacks like black hole, DNS, those type of attacks are not like generally spoken in resiliency. It's spoken in chaos engineering. Okay, so yeah, in that way we can point out. But again, it's a, as Mayank correctly pointed out, it's a subset. Okay, like it's more sort of aeronautical and aerospace. So aeronautical students might not know regarding space, but aerospace guys might know, right? So in that way, yeah. But resiliency is gone. Okay, see that is there. Resiliency testing is gone. Now it's only chaos engineering in everywhere. No one speaks about resiliency nowadays. It's only either like because it's already covered in chaos, right? So we don't need resiliency again. So yeah, yeah. Someone send in. Sure, sure, Tofim. I will. Yeah, sorry. Uh, I will share with my team, Tofim. Actually, yesterday they were going to contact, but they couldn't contact. We will. Even others can also share me your email or your numbers. I can share with my team. They will contact you if anyone has any queries regarding how to proceed to the next sessions and all. No? So okay. So any other queries, or else we can stop here and we can jump into. Oh, it's not anyway weekend, right? We still have some work.
So Vishnu, to contact you, can you share the number?
Yeah, it's in WhatsApp, no? I am already in WhatsApp, so you can share. You can contact me in WhatsApp always.
Okay, the group which
Yeah,
was created, right?
correct, correct. Yes.
Okay,
Yeah.
okay, thank you.
Okay. So I will try my level best to see, like anyone here other than performance engineering, like someone from automation or some way in that way. Like, what's the audience like? How are? I just want to try to understand because then if I then I can incline more to that domain. Okay, so that it will feel more closer to them what they are doing already. So I guess all are from performance, right? Mainly. Mayank, did you shift to something new?
Yes, sir. I left
Okay,
TCS.
what? Okay, okay, yeah, yeah, yeah. Because you are feeling more energetic nowadays.
No, sir.
Yeah. Okay. Anyways, thank you all. Then have a good weekend. Meet you all on Monday. Thank you.
Thank you.
Thank you, sir.
Thank you.